Hey everyone, welcome to the Flight Deck. Today, we're buckling up for an absolute masterclass on flight and fuel planning. We're specifically tailoring this explainer to help you completely dominate the DGCA CPL Air Navigation exam. Now, if you're an aspiring commercial pilot, you already know the DGCA doesn't just test your memory, right? They test your logic, your discipline, and your ability to really think like a professional aviator under pressure. So grab your calculators and get focused, because we're going to build your conceptual foundation right from the ground up and make these calculations basically second nature. Let's start with a real-world scenario to put you right in the pilot's seat. Picture this. You're commanding a Boeing 767. You're flying from Santiago, Chile, all the way out to Easter Island. It's a stunning, incredibly isolated destination sitting right in the middle of the ocean. It's a 2,029 nautical mile journey, and here's the kicker. Once you cross the Chilean coast, there are absolutely zero en route alternate airports. None. If you get all the way out there and the weather has suddenly tanked, or maybe the single runway is blocked, you literally cannot just divert to a nearby field. So the multi-million-dollar question is, can we safely fly this route at all? Well, as the pilot in command, you have to know your absolute point of safe return before you even commit to flying over that ocean. Okay, let's dive into this. Here's our flight plan. 1. Concepts explained. 2. Numbers and formulas. 3. DGCA exam focus. And 4. Quick recall. Starting off as Section 1, Concepts explained, looking at fuel policy and PSR. So every professional flight plan is a delicate balance of safety, performance, and of course, fuel. Your total endurance, flying until the tanks run bone dry, is never what you actually use to plan a flight. A standard commercial fuel policy breaks your fuel down into very specific buckets. You've got your trip fuel to actually get to a destination. You have contingency fuel for unexpected weather or routing changes. You've got alternate fuel to reach your diversion airport, and your final reserve fuel, which is your absolute unbreakable emergency safety net. Now, for our calculations today, what really matters is your safe endurance. In the cockpit, your safe endurance is the fuel you actually have available to burn on the outbound and return trip before you start eating into those mandatory alternate and final reserves. Fun fact, in the commercial world, dipping into your final reserves literally means declaring a mayday. You absolutely must preserve those reserves. And that perfectly sets up the exact definition of the point of safe return, or PSR. The PSR is the absolute maximum range an aircraft can fly outbound on a route and still turn around and return to the departure airfield while keeping its safe fuel reserves completely intact. Now, I really want you to remember this. Passing the point of safe return is not an emergency procedure. It's actually a standard, routine operational plan for isolated routes. It basically just means that right before you hit this point, you double-check your destination weather. If it looks bad, you turn back. If it's good, you proceed. But once you cross that invisible line, you're committed. You physically do not have the fuel to go back. Okay, listen up, because here is a massive point of confusion for a lot of students. You have got to separate the point of safe return from the point of equal time, which is also called the critical point, or PET. PSR is strictly a fuel problem. It's entirely about how long your fuel lasts, which means the actual distance to your destination is completely irrelevant. PET, on the other hand, is a time problem. It's used for an emergency scenario, like, say, an engine failure, where you need to know the absolute quickest time to reach the nearest alternate airport. So for PET, the distance between airfields is essential. To sum it up, PSR is fuel and routine, PET is time and emergency. Make sure you don't mix those two up. All right, moving into Section 2, the numbers and formulas for calculating PSR. So the heart of all this is the PSR formula. To find the time it takes to reach the point of safe return, we use this exact equation. T equals E times H divided by O plus H. Let's define every single one of those variables in plain English so it really locks in. T is the unknown time to turn back, which is what we're solving for. E is your safe endurance. And remember, that's your total fuel minus your required reserves. O is your outbound ground speed heading towards your destination, and H is your homebound ground speed for when you turn around to come back. Let's put this into practice and walk through a full worked example step by step. Let's say your true airspeed, or TAS, is 300 knots. You've got a 50-knot headwind on your way out, and your safe endurance is exactly 10 hours. Step 1, identify those variables. Step 2, let's calculate your outbound ground speed. You're fighting a 50-knot headwind, so 300 minus 50 gives you an outbound speed of 250 knots. Step 3, calculate your homebound ground speed. Now think about it. When you turn that aircraft exactly 180 degrees to go home, that annoying headwind suddenly becomes a tailwind. So 300 plus 50 means your homebound speed is 350 knots.
Step 4, plug it all into the formula. T equals 10 times 350 divided by 250 plus 350. That gives us 3,500 divided by 600.
You crunch those numbers and you get 5.833 recurring hours. But we obviously don't speak in decimals in the cockpit, right? We need to translate that. 0.833 of an hour is exactly 50 minutes, so your actual time to the point of safe return is 5 hours and 50 minutes.
But wait, what if the exam asks for the distance and not just the time? It's incredibly simple. Distance equals speed times time. To find the distance to your PSR, you just multiply that time t you just calculated by your outbound ground speed. So we take our 5.833 hours and multiply it by our outbound speed of 250 knots. That gives us 1458 nautical miles. That is exactly how far you can fly out over that ocean before you absolutely must turn back.
Now, this brings us to a massive aerodynamic rule you really must commit to memory: the wind rule. Compared to a still air scenario where there's zero wind, absolutely any wind component, whether it's a headwind or a tailwind, will always reduce your maximum PSR distance. You might be wondering why? It's because you will always lose more time by slowing down on the headwind leg than you will ever gain by speeding up on the tailwind leg. The math proves it every single time. Your maximum possible range is always going to be found in still air.
Next up, Section 3, DGCA exam focus. Let's talk about beating those traps.
All right, red alert. Here's the absolute biggest examiner trap you are going to see, and they do this entirely just to trick you. They love to give you the total distance to the destination in a PSR question. But remember what we talked about earlier, PSR is a fuel problem. The distance to the actual destination has absolutely zero impact on how long your fuel will last in your tanks. Let's look at a classic DGCA-style multiple-choice scenario. Your total endurance is 7 hours and 40 minutes. Your required reserves are 1 hour and 40 minutes. Your true airspeed is 200 knots. The distance from departure to destination is 1,200 nautical miles. The outbound wind is a 30-knot tailwind. Find the time to the point of safe return. Let's break this down methodically. Step 1. Find the safe endurance. Students so commonly make the mistake of using the total endurance. Don't do that. Take your total 7 hours 40 minutes and subtract that 1 hour 40 minutes of reserves. Your safe endurance, your E, is exactly 6 hours. Step 2. Notice that 1,200 nautical mile destination distance? Ignore it completely. It's pure bait. Step 3. Find your speeds. Outbound has a 30-knot tailwind, so O is 230 knots. When you turn around, it becomes a headwind, so your homebound H is 170 knots. Step 4. Apply the formula. T equals 6 times 170 divided by 230 plus 170. Do the math, and it equals 2.55 hours. Now to convert that for the exam answer sheet, 0.55 times 60 minutes gives us exactly 33 minutes. So your final correct answer is 2 hours and 33 minutes. If you had used the total endurance or tried to awkwardly factor in those 1,200 miles, your answer would be completely wrong, and you can absolutely bet the DGCA will have that specific wrong answer waiting for you as an option.
Finally, Section 4, quick recall. Time for a 60-second rapid revision.
Here is your pre-exam cheat sheet. Read it, memorize it, and lock it in before you walk into that hall. Rule 1. The PSR formula is time equals safe endurance times homebound speed divided by outbound speed plus homebound speed. Rule 2. Distance to PSR is simply that time multiplied by your outbound ground speed. Rule 3. Safe endurance is your total fuel minus all required reserves. Never, ever use total endurance. Rule 4. PSR is strictly a fuel problem. If they throw the distance to the destination at you, ignore it. And Rule 5. Any wind, whether it's a headwind or a tailwind, will always reduce your maximum PSR distance compared to flying in still air. To wrap this explainer up, I want you to remember a thought that applies just as much to your exams as it does to your future aviation career. The cockpit rewards disciplined people, not rushed people. Take your time, follow the methodical steps we covered today, and whatever you do, don't fall for the examiner's traps. But I want to leave you with a question. If a simple headwind dramatically shrinks your PSR distance, what happens when a sudden en route storm forces a massive diversion before you even reach that point? The sky is dynamic, right? And so are your calculations. Head over to clouddeck.in to hammer out some practice questions on flight planning, prepare for the unexpected, and I will see you in the next explainer. Fly safe.